Hello, this is Mike Liva, and this is our fourth video in hacking Papervision. And last time we actually had fixed a proto class camera 3D, and actually errors inside of the object 3D begin to pop up. So sometimes errors hide other errors, and you just have to go through the entire process until you've actually kind of recursively fixed everything. Now, I just want to point out now, once again, we're going to fix this number 3D.0 problem. So last time what we did, we replaced all the number 3D with vector 3D. And we still have a series of errors here because there's no zero method in the Flash player. So how do I know that? Well, once again, I have to open up the code. We'll call it the old code that we created, that we're replacing, and see and look at the method. And I've got that right here. I actually copied it in my Word document. You'll have all these notes on the blog, by the way. So what I have inside of this number 3D class is this number 3D.0 method. And what that actually does is just return zeros. And so I know that just by going back to the class and examining it. So many times you're going to have to do that. You're just going to have to click on the class and go take a look at that, and there it is right there. And that's what I need to replace. And we've already seen that if you go to the zero, if you replace this by new vector, we'll put new, and we'll put a little parenthesis here and start the code hinting. What you see in the code hinting, let me change this so you guys can see that. What you see in the code hinting is exactly what you saw in the method. It sets x equal to 0, y equal to 0, and z equal to 0, and w equal to 0 in this case. And that's all you need to do is replace all of those with new vector 3D, and that will fix your problem. So I'm going to come along here and just copy this, Control C, and I'm going to highlight each one of these and just replace them. And as soon as I hit save, a number of my errors will go away. And that's so marvelous about Flash Builder, is to click on something and it actually just does the entire check and removes your errors. But I see another bar here. Let's click on that and see what the problem is. And I've got a get position here, and let's fix that. So when it comes to these replacements, half the battle is figuring out what the error is. It's actually not the position vector. That's actually a 3D vector that I'm creating. But it's actually the reset method. So what does that do? Let's go to number 3D and take a look at that. Well, all it does right here is just puts the new values in the vector. So let's go ahead and do that, and one way to do that is just to use new vector. So in this reset, I'm just going to take this and just set it equal to a new vector, equal to new vector 3D. And what it does is it creates a new vector 3D and shoves these quantities x, y, and z into them, exactly what's being done in the number 3 method, except now it's being done in the Flash player. Let's hit the save button and see if our error goes away. And it does indeed. Now, and a bunch of other errors have appeared. So sometimes errors hide other errors. So let me bring that up so you can see them. And I can see a whole bunch of them right here. So let me click on the first one. And now I have, once again, my reset method. Boy, this is going to take me a long way. So I'm going to come along here and just set that equal to new vector 3D. And hit OK. Once again, just below that, there's yet another problem. And let me just grab this and copy and paste it. So this reset is actually taking me a long way, getting rid of a lot of these problems. Here we go. Paste that. And it just takes a lot of patience just to go through this step by step. Here's the error once again. Paste that. And fix them. And you have to be patient, and you have to be careful that you get the right replacements. If you get the wrong replacement in there, you're going to really be sad. So let's go and paste that. And now we actually have a new problem. It's called copy from, look at target, minus equal, normalize, modulate, and cross product. All really cool stuff to explain. And so let's get to it. So I've got another error, and this is the copy from error. And actually there's a number of ways to take care of this. So what I'm actually doing is I'm taking the look at target vector, and I'm going to copy from that and put it in the z-axis vector. And there's a number of ways to do it. Once again, you might just use your new method, or you might use a clone method. Go back to number 3D. You can actually see what these definitions mean. Here's copy from right here, and what it's actually doing, if we're in number 3D, that's the old program, it takes a vector and just divides it up into its x, y, and z and copies it into a new x, y, z. That's pretty cool. Let's take a look at clone method. Clone method, actually what it does, it takes a new number 3D and takes its x, y, and z and returns a new number 3D. So pretty much very similar operations. So let's go back to our method now. And we're taking the x, y, z of the look at target and we're putting it in the x, y, z of the z axis. So let's see if there's a method that actually does that for us. But what I'm going to do is use a dot right there, and it gives up all this code hinting. And what this code hinting actually is not the code hinting from number 3D, but the code hinting from vector 3D. This is my best friend here, because I can come along here and see if I can find a method that actually matches the copy from method. So I actually have two options, and it just takes a little thinking about it, and sometimes you get it wrong. You have to run the program, it doesn't work, and go back and do it again. But really all I'm really doing in copy from is setting this vector equal to that vector. And I could do that using a clone, or creating a new vector and set it equal to that, or I could just basically set the vectors equal to each other. Let's just try equals. So I'll come along here, just set one vector equal to the other. And let's see if the error goes away, and we're going to cross our fingers. We're going to look at that program and see if it works. And the other option is to use a clone. Okay. Now let me tell you where I get in trouble with this and why clone might be a better option. Is sometimes when I set one vector equal to another, what it does that basically like a binding. And so whenever this vector changes, the other vector changes as well. And I don't necessarily want that to happen. So you have to be careful, and you have to just see if everything's working correctly, and if you have to change. So I'm leaving this commented out. I may have to come back and use this because that one method may not work. And sometimes there's trial and error. But let's see what happens. So next I want to use a minus equals. What the heck is that? Once again, let's go back to number 3D and look at minus equal. So I'm going to copy this, go to my number 3D method, and I'll just do a Control F and find it. Paste it in there and find. And there's my minus equal, and all I'm doing basically is I'm decrementing the entire vector. So we're typically used to doing this with one dimension, and when you do a minus equal, it decrements by the actual vector itself. But we're actually going to do this for x, y, and z. And so let's see if there's a decrement and increment method that does this for us automatically in the Flash player, and there is indeed. And the way I find that method, I'm going to come along here. I'm going to get rid of the minus equal. Excuse me, went too far there. Get rid of the minus equal here. And I'm going to hit a dot and see if I get a decrement method. And there it is, decrement by, and that's all you have to do. And so now you're actually decrementing by the entire vector. So we've added our decrement function, our error has gone away, and now I want to point out another mathematical function that's called normalization. This is the exact method that's in the Flash player. For example, if you go ahead and dot click, you'll see normalization right there. So actually this is in number 3D, this is in vector 3D. What is that actually doing? So let's actually go to the number 3D program, and let's see. So let's bring a number 3D program up there. I'm just going to come to the top of the program because there's a lot of lines of code. I'm just going to use my Control F to find it, so I'll get to normalize. And let's find that. So what does normalization do? I mean, this is a very interesting idea. And basically what it does, it just unitizes your vector, such that whenever you dot it against itself, you get a normal vector, a unit 1 vector. So the way to do that is to actually take your vector and get the length of it. So that's x times x plus y times z, and square root it. And then what you do is you invert that, and you multiply it by each component of the vector. And that's how you find a normalized vector. It's a very useful quantity, and we'll be talking more about that math in the future, but that's how it works. Along with this is also the idea of length or modulo. So let's go back to the program. This was already automatically in the Flash player normalization because it's such an important quantity. But what you don't see here is this modulo. What the heck is that? And what modulo actually is just length. Let's go check out the number 3D class just to make sure that's right. So we'll type in Control F modulo, and I do this because I'm lazy, because I'm too lazy to search through all that, and I'll let the computer do it for me. And here's the modulo method right here, and basically this is the method for finding the length of a vector. So x times x plus y times y plus z times z, and to take the square root of it. And this is called the metric, or the length of that particular vector. And so that's what's actually doing. So we'll just use the length method that's in the Flash player. So if you come along here and you hit a dot here, it shows you all the particular functions or methods in the Flash player, and there's a length. It will get the length of the vector, and that's really all that was. So what we need to do now is talk about this cross product, and I think we're getting close to fixing the display object. And we'll do that next time.